Modules in Python. Hello, good morning. Modules in Python are just Python files. That's all a module is. It's just a Python file. That's it. That's it. Nothing else. Nothing else. It's that simple. They're just files. At the end of the day, after I've covered all the little sugar and syntax of how we import them and how we use them, keep in the back of your mind, keep in mind that we're just talking about files. We're just talking about another something.py file somewhere else. That's it. Modules are a way to reuse code. So I can write some very useful code. I can put it in one file. I can organize a bunch of useful functions, classes, whatever those are, variables, whatever else I might be using. And I can put that all together in a module, which is just a file. And I can keep it separate from my main project, which means I can write 5 different projects that all use the same module. It also means I can update these modules independently and I can fix bugs. It means I can work on a team where somebody is working on one part of the code and I'm working on another part of the code. It means, perhaps most importantly, I can just stay organized and I can just have a file that has a name that tells me what's in the file and what it does. And when I open up web request utility.py and I look at all the code there, it's all related to the same thing. Very useful. And perhaps most importantly, it means I can use code written by somebody else. Okay, let's get into it. Modules. I have a module, a function here. And let's make a new module. Let's make a new module. So how do we do that? It's very simple. I can make a module just like I can make anything. Is I just make a new .py, a new Python file, which I can do here from File Explorer, test.py. But that would be silly. I made a text file. That would be silly. Don't do it from that. I'm in PyCharm. I'm going to do it from here. I'm going to right click on the root folder of my project or whatever folder I'm in. Make a new Python file, and I will call it test.py. What a name. And in my test.py file, I am going to move this name code where I define the variable called name, and I'm going to move it over here. There we go. And now when I run the main file and I hit play, I should get an error. I didn't actually show you the code working, but you can probably take a guess at what it did. We'll skip that part. It shows me an error because that variable is not defined. To define it, I would need to go to this function, copy, paste the entire script, which in here is just one line, and paste it at the top. And I'm going to do basically just that by importing the name of that file. I don't have to type .py. But what I'm typing up here, where I define the name of the module, is the name of the file. And we tend to keep everything lowercase. I wrote this one uppercase. We're going to make that, I'm just going to rename that to be lowercase. When I renamed it in PyCharm, it renamed it in both places. How convenient. And I still have an error. And if I hit play, I should still have the error. Because I need to say that I am looking in that other module, whatever my name is here, and then followed by a dot. And inside of that dot is whatever, function or variable or so have you that I have in there. So now, finally, I can get the name variable in the test module, and I can use that in my code. And there we go. It's got that code from this other file somewhere else. Excellent. You may have noticed in my video, I have another file here called name utility. It contains 1,000 functions. Nope, just one, but this is an example where I have a bunch of utilities for working with names. Perhaps, I would guess, from the name of the module. Again, we're in an example and there's only one function here, but. And here I have a function called get first name only. So let's use that one. First underscore name is equal to get first name only test.name. And of course I have the exact same error as before because this function is just hanging out in a different file and we don't know that we need to run that code. We need to import name underscore utility.py, but we don't need the .py. And then I need to type the name of the module followed by a dot. And once I do that, all my errors go away. And I can now print just the first name. So my Python, hi, my cat has appeared. My Python file now grabs a variable from one module, it grabs a function from another module, and it uses both of them in this one line of code. And that's super useful. I basically only have a single print statement as the code in this file. I have like 2 lines of code, and I'm doing more things than that, almost 8 whole lines of code. But you can imagine how these get more complicated. So let's clean this up a little bit. I'm going to get rid of this test file because having a file named test sitting around is annoying. So I'm just going to sort of replace it and bring it back into this file because I don't need it. Let's run the code. Yep, still works. Great. So when we import a module, when we run this import statement, what do we think is actually happening? I've described it as copying and pasting the code, but that's not quite right because if we did, we wouldn't need to type this dot here or this name utility dot. But let's put a print statement right in our code. And let's just say like hello from main utility. And then we can go back to main and I can run the main function. And I can see that before this print statement, up at the very top, it ran hello from name utility. Interesting. If I put a print statement above that, would it go first or second? Would it do all the imports or would it do it when it found it? Let's find out. Python in fact does what Python always does, which it starts at the top and goes down. So when we ran this import statement, first the first line happened, then this import statement happened, which basically moved us into this file and ran all this code and then brought us back. And then we were able to keep going and we now had access to the functions that exist in that other file, with the addition that we need to type this little dot. By convention, most programmers put all their import statements right at the top of the file. This way, when there's an error or a bug with import statements, we tend to hit them first before our code starts running. And that makes the error messages very easy to find and chase down because we know that our modules are all referencing and working. And then our code starts hitting its problems and errors and whatever else we're trying to fix. And the other reason we do that is because it's just easy to read. That's probably the main reason we do that. But you will see that programmers, if a module is only being used in one function, and that function maybe isn't getting called all the time, we might only import that function when we need it. So we might import that function only inside right when we need it. If this function, maybe we're doing like a web request or send crash report or something that has to upload suddenly. Now we're going to import that like upload to the internet code, but only run it if it's like pretty rare. I don't see that too often. I think most programmers tend to write their code with the import statements all up at the top. And as I try to think and type at the same time, and then perhaps later when we're trying to optimize our code or maybe make it a little bit cleaner, we might move some of those import statements if they're only being used in one function and that function isn't being called very often or might not be called during a program's execution, more to say. Okay. So typing the name underscore like module name dot is kind of annoying and I don't want to do it. So let me quickly show you a couple of nice tips for cleaning that up. The first is my absolute favorite thing to do, which is to rename the module when we import it. Just for the file that we imported in, we give it a new name. Here I've used the initials, which is not an uncommon thing to do, even though it makes the code harder to read. Using the keyword as. Import something, but give it this name, please. Thank you. Okay, good to go. Good to go. Run the code, still works. Yep, good to go. Great. There are some common conventions with that. Often you'll see Pandas, a data science library, imported as PD. You'll see some, there's this graphics cards library that I was using for a while that I just imported as G, and now I'm terrified of typing the letter G because it's going to refer to something else. But like that's a little bit hard to read, and that's kind of annoying. So, but one of the reasons that we do that is because when we publish modules that we download from the internet, they need unique names. So often modules have kind of silly names, and we import them and give them a little bit more sensible names that are still clear and easy to read in our code. Okay, next, let's say I don't want to type that dot as all. I want to be able to call this function directly, and that's going to be using a nifty from syntax. So this goes before the import statement, but from the name utility script, I'm going to import the function. And when I use this, it's basically still, and delete that line because it doesn't do anything now. It basically still imports the entire name utility. It still runs that import, but it gives me, it still runs the code in the from, but it gives me the functions that I have asked for in a very specific way, and it moves them into this scope. So I don't need to type name utility dot. I can just type the name directly because I've defined it here. I've said this name refers to the one from that function over there. So that's very useful. You're going to see that all the time. And then finally, actually, that's it. There we go. What am I typing? I'm trying to think and type at the same time. There we go. Back to square one. That from syntax, you can do comma separation. And let's take a look at that in a real life project. So here I have a real project, and I have a module called Markdown Tasks, where I have written some utilities for saving and opening a Markdown file and finding things that look like to-do lists in them. And in my main project that I'm using, at my top, I have all these different import statements. I have my import statements for this other library somebody else wrote that I'm using. I have my system imports that I need for the file writing. And I have Markdown tasks right here. I'm just importing the whole thing. But from the a second module, which contains the UI elements, basically, I am importing just the ones I need. From that one really big library that has tons and tons and tons and tons of stuff, I'm importing just the things that I'm actually using. And that's it. So you can see that the import statements have gotten kind of messy and complicated, but having imported all of these separately means I can type those all directly, and I don't have to type textual.app.composeResult or textual.binding.binding. I can just import it and just use the names directly, which is much more convenient. Back here. Okay, one very important final thing to cover, which is how we can figure out if the code we're running is contained in a module or not. So let me head over to the name utility. We see over this print statement. I'm going to change this up just for the example. Name utility, what am I doing? The name, oh my God, I hate the syntax. The underscore underscore name underscore underscore variable in name utility is underscore underscore name underscore underscore. And I go to my main.py and I can do this. I'm going to copy and paste this. Copy. Go to main. Paste in main.py. And I run my main code and I see that the underscore underscore name variable in main.py is underscore underscore main, M-A-I-N, is the name of the name variable in main.py. That was a horrid sentence. But the reason that this is called main.py is by convention, because we refer to main as the sort of entry point or starting point of Python. And by convention, that is the name of this name variable. The name variable is refers to sort of the current execution environment or scope that we're in. So if I go to the name utility file and I run this file as if it were its own Python file and I hit play, it says that the name variable is equal to underscore underscore main. Good so far. All right. If I run main now and hit play, I can see I actually have all of the code from name utility is running. And it says the underscore underscore name underscore underscore variable in name utility is not main anymore. It's name utility. It's the name of the thing that we need to type the dot to get. And then the variable in the Python file that I actually ran by typing, Python space main.py, right? Just when we run the Python code, which I did by clicking this green checkbox, is equal to __ main. So this is how I know if the code I'm running is the code that I ran by hitting play, or if it got imported as a module. So there's a very common pattern that we will see all the time in our modules. And that pattern is if name is equal to main. So I'm going to get rid of that line and replace it with this one, name utility run directly. So I go to my main code and I hit play. The only code the only print statements we see are the two from this main.py function. Line 5, which printed my name, and line 7, which told me that the name variable is called main. Over in name utility, because the name variable was equal to name _ utility when it was imported, then this code did not run, it skipped it. But if we were to go down to the current file and run that code instead, I would see that name utility run directly. So just to really drive it home, let's add another print statement, name utility ran as module. A little else there. Run directly. When I run it directly, I can go to main.py, switch over to that, hit play. Name utility ran as module. So now I have a way of figuring out if my code is being run directly or as a module. I feel like I've said that 10 times. But that's super useful, and we use it all the time. So to go back to my markdown thing, this is messy code, but whatever. I have if name equals main, there it is. And then I open a file, I add a task to the file, and I save the file and close it. And that's all that happens when I run this code directly, is it runs a little test, and I can go and I can see, oh, hey, it worked, or it didn't work, or something broke, or whatever. And then I finished writing all that code, and now I don't really need the test, but I still have it. It's still useful to have that little test hanging around. It would be more useful if I made it more exhaustive and like an actual test and not like debugging, but it's there. But then I go back to my actual project that's running, which is, a little to-do list software, which breaks in this terminal, so whatever. And it doesn't run that code. It didn't add tasks to my to-do list every time I open the file. That would be very annoying and bad. If name equals __, if __ name _ is equal to _ main _ then we run directly. Those underscores if those seem inconvenient, the answer is they are correct. They are inconvenient. They are unlikely to conflict with the variable names that you are using. So by convention, we're using that to often refer to internal Python things or private things, and some other features that will be more important as we learn more about modules and importing and exporting. Okay, we're done, but I got one more thing for you. I know, I'm sorry, stick around. I got one more thing for you, which is the Python standard library. And oh my gosh, look at all these modules we can import and use. And we've probably already used one, random. And there's also the math library we use all the time, math. All the little functions we want and need, math.random. We love it. It's so good. So if I was, printing a random number between 1 and 20, then I would want to use the randint function, but that function only exists in the random standard library, which is just a module. The random module in the Python standard library, there it is. And I'm going to get an error because it can't find random. I need to go to the top and type import the name of my module. And I did not convert this number to a string. There we go. All right, thank you, Python. Okay, random number between 1 and 20, 12. Run that again, 6. Great. Is this inclusive or exclusive? I might be doing that wrong. Less than or equal to, less than, okay, it's inclusive, great. Anyway, so it could be 20, right? I didn't make a random number between 1 and 19, and you never roll a critical hit in D&D. Oh, tragic. That would be funny. It would be bad, I mean. Okay, so you may notice that there's no random.py function in my folder. This folder is somewhere else. It is in the Python standard library. It is included in Python. When we do the import statement, it searches the folder that we have here. Then it searches through the modules we've installed. Ooh, what does that mean? Then it searches through the standard library. And there's a certain order that it searches in that is often a cause of bugs if you don't name things in unique ways. But Python is looking in more than one folder for these modules. It looks in a number of folders in a certain order. That's called the path. And oh boy, that's your next step to Google, because it turns out other computer systems work the same way, and that's a useful thing to know about. So that is modules. That's what I got for you. There you go. I hope this was a helpful review.